Pearson's Correlation. Use dataset _3. Pearson's Correlation. Pearson's correlation is used when the normality assumption is met. Example, both the dependent and independent variables are normally distributed. Assumption 1. For example, we want to explore if there is a correlation, association between systolic blood pressure, BP, variable name is SBP, and diastolic BP, variable name is DBP. Hypothesis H0. There is no correlation between systolic and diastolic BP. HA. There is a correlation between systolic and diastolic BP. Scatter diagram. The first step before doing the correlation analysis is to generate a scatter diagram. The scatter diagram provides information, ideas about whether there is any correlation between the variables, whether the relationship, if there is any, is linear or nonlinear, and direction of the relationship, i.e., whether it is positive if the value of one variable increases with the increase of the other variable, or negative if the value of one variable decreases with the increase of the other variable. Scatter plot. To get the scatter plot of systolic and diastolic BP, use the following commands. Graphs next, scatter, cheat dot. Next select, simple scatter. Next, define next select, SBP for x-axis and DBP for y-axis, next select ID no for level cases by. This would label the outliers, if there is any, by its ID number. You may omit it if you like. Next, OK. Scatter plot. Commands for Pearson correlation. Analyze next. Correlate next bivariate. Next select the variables, SBP and DBP, and push them into the variables box. Next select Pearson under the correlation coefficients, usually set as default. Next. OK. Findings and interpretation. For correlation, look at the value of Pearson's correlation. Table shows that the correlation coefficient, Pearson correlation, of systolic and diastolic BP is 0.847 and the p-value is 0.000. Correlation coefficient, A-R, indicates the strength degree of linear relationship between the two variables, systolic and diastolic BP. As the value of R is positive and the p-value is less than 0.05, there is a significant positive correlation between systolic and diastolic BP. Spearman correlation. Spearman's correlation, instead of Pearson's correlation, is used when the normality assumption is violated, i.e., if the distribution of either the dependent or independent or both the variables are non-normal. Spearman's correlation is also applicable for two categorical ordinal variables, such as intensity of pain, mild, moderate, severe pain, and grade of cancer, stage 1, stage 2, stage 3, etc. Suppose we want to determine if there is a correlation between systolic BP, variable name is SBP, and income, where income is not normally distributed in the population. Spearman's correlation is the appropriate statistical method to test the hypothesis in this scenario. Commands: analyze next, correlate, next bivariate, next select the variables SBP and income and push them into the variables box. Next select Spearman under the correlation coefficients. Next. OK. Findings and interpretation. Table shows the Spearman's correlation between systolic BP and income. The results indicate that there is no correlation between systolic BP and income. Arjifran 0.007, p-Potters 0.919. Since the RR value, correlation coefficient, is very small, and the p-value is greater than 0.05. Thank you.